Hi, I'm Dimitris, and in this presentation we're going to have an introduction in arithmetic sequences. Before giving the definition of an arithmetic sequence, we'll start with some examples so that we can understand more easily its concept. Look at the numbers 5, 8, 11, 14, and so on. Notice that by starting by number 5, we add number 3 each time we want to get a new number. Indeed, 5 plus 3 equals 8, 8 plus 3 equals 11, 11 plus 3 equals 14, and so on. Now, look at the numbers 9, 7, 5, 3, and so on. This time, starting by number 9, we subtract number 2 each time we want to get a new number. Indeed, 9 minus 2 equals 7, 7 minus 2 equals 5, 5 minus 2 equals 3. Now, having in our minds the previous two examples, we are ready to give a definition. An arithmetic sequence, or else arithmetic progression, is a sequence of numbers in which each term is given by adding a constant number to its preceding term. This above definition can be expressed recursively by the formula a sub n plus 1 equals a sub n plus d, where a sub n and a sub n plus 1 denote two random successive terms, and d symbolizes the constant difference between them. Often, some books define an arithmetic sequence as a sequence in which the difference between one term and the next, or previous, is a constant. That's why they give the following formula: a sub n plus 1 minus a sub n equals d. This formula is useful in exercises where we know two consecutive terms of an arithmetic sequence and we need to find the constant difference d. For example, if numbers -3, -1, and 1 are successive terms of an arithmetic sequence, find the constant difference. All we need to do is just find the difference between a pair, any pair we want, of consecutive terms. Hence, d can be calculated as the difference of numbers -1 and -3, and we would write d equals -1 minus -3, which would equal to number 2, or we would just calculate d as a difference of numbers 1 and -1, where in that case we would write d as 1 minus -1, which again would lead us to number 2. Now, the general formula of an arithmetic sequence is a formula that gives us directly the nth term of a sequence by simply knowing the first term and the constant difference d. It is described by the type a sub n equals a sub 1 plus n minus 1 times d. Let's see an example. If the first term and the constant difference of an arithmetic sequence are numbers 2 and 6 respectively, find the 11th term. In our solution, we'll begin by translating our given data in mathematical expressions. Thus, a sub 1 equals 2, d equals 6, and we are looking to find the term a sub 11. Now, we will just use the general formula, and since we're looking for the 11th term, we'll substitute 11 in place of n. Hence, we start by writing the general formula, which is a sub n equals a sub 1 plus n minus 1 times d, and then we'll substitute our data. A11 equals 2 plus 11 minus 1 times 6. A11 equals 2 plus 10 times 6. A11 equals 2 plus 60. And finally, A11 equals 62. For any questions about this presentation, you can leave comments down below, or you can contact me with one of the following ways, either on my email or in my Facebook page. Once again, thank you for your time.